So our next lesson would be calculating resistor values in a circuit. We know that resistor limits the flow of current or produce a desired voltage drop. So imagine a faucet with a flowing water. So the amount of water is now our current. It represents the current. And the pressure of the water is our voltage. So the valve now is which controls the flow of water is our resistors. Calculations are derived from actual experiment. So it is actually done by a famous German physicist, George Simon Ohm. So the experiment is a very simple circuit with a current reading connected to the voltage source, which is our batteries, and connected to a very special type of metal, which is what we call a nichrome wire, with a length of 0.5 meter. So if remember, all materials that exist in this world, in this universe, has resistance. But metal wires has a very small resistance that allows electricity to flow. So we are going to simulate the actual experiment done by the German physicist George Simon Ohm. Okay, so we have here a single cell battery. So our battery is around 1.5 volts, passing through a switch, passing through the current reading, and to our nichrome wire. So as we turn off the switch, we would have a reading of a zero point 0.6 ampere of current passing through the circuit. Okay, so if we increase the voltage or the cell or additional battery, we would have now a 3 volt voltage source. So we add 1.5 plus 1.5, we would have 3 volts. So how much current will be flowing now to our nichrome wire? So we have a 1.2 ampere if we have a 3 volt voltage source. So if we add another cell of battery, so addition of another cell of battery, making it 4.5 volts. So our current now passing through the nichrome wire is equal to 1.8 ampere. So the relationship of the voltage now and our current, as we increase the voltage source, the current passing through the nichrome wire would be higher current. So we are going to collect our data based on our simulation just to prove the experiment done by George Simon Ohm. So the leftmost column will be the number of cells, so the number of batteries we add, voltage across the nichrome wire, the current through the nichrome wire, and the ratio of voltage and current. So having one cell, the voltage across the nichrome wire would be passing just 1.5 volts. Okay, remember that as our experiment, we get the value of 1.5 because 1.5 is the value of our cell. And the current through the nichrome wire is a 0.6 ampere. As it appears, sometimes it appears on our reading would be 600 milliamp. And we get the ratio of voltage and current. So V over the current is equal to 1.5 divided by 0.6, which is equal to 2.5. As we add the number of cells, we make it 2, we could have 3 volts across the nichrome wire. So our current now flowing to our nichrome wire is read as 1.2 ampere. And we get again the ratio, which is equal to 2.5. As we add again our cells, we make it 3 cells. We get the voltage now is 4.5 and our current now is 1.8 ampere. And again, our ratio would be 4.5 divided by 1.8, which is equal to 2.5. So as we increase the number of cells, the voltage across and the current through the nichrome wire increases. Okay, as you observe, the voltage, all the voltage, even if we add up our number of cells, we also increase our current. Okay, now why is it the ratio of voltage to current is constant? You notice if our cells is 1, we have 2.5. We add our cells, we have 2 cells, now it's still 2.5. We add another cell which is 4.5 volts, still we get 2.5. Because our nichrome wire remains constant, which is 0.5 meter in length. So our ratio would always be constant. And we refer it to a symbol of omega. So our symbol for resistance is omega. Ohm's law. Based on his experiment, he observed that as we increase the voltage, the current also increases. And as current increase, the voltage across also increase. And the ratio of voltage to current is constant. This is also based on our simulation. So the constant now is what we term as resistance. And our value, our unit for resistance is ohm. And the symbol would be omega. Now the formula. So based on Ohm's law, we would derive the formula of voltage, current, and resistance. So voltage is directly proportional to current because as we increase the voltage, we also increase the current. And voltage is directly proportional to resistance. As we observe that as the higher the resistance, the higher the voltage across that resistors. And current is inversely proportional to resistance. Or vice versa, that resistance is inversely proportional to current. So based from the observation, we could now derive a formula. As you notice that voltage is directly and proportional to current and resistance, we could say that voltage is equal to current times resistance. And as we notice that current is directly proportional to voltage and inversely proportional to resistance, we can say that current is equal to voltage divided by resistance. And we can say that resistance is directly proportional to voltage but inversely proportional to current. We could say that resistance is equal to voltage over current. Okay? So based on this formula, we could make our own mnemonic, which is the Ohm's triangle. Okay? So if you are looking for the voltage, we just cover the volts. We will just cover the volts and we could have a formula of I times R. And if we're looking for current, we just erase current and we could have the formula V divided by R. Okay? And if we are looking for the resistance, we would just cover the resistance R and we could have now voltage divided by the current. So never forget the Ohm's triangle. So we'll apply it to a simple circuit. So So a simple circuit, we have a voltage source, which is the long line. If you see the symbol, we have the long line which has the positive side, and the smaller line is our negative side. So that is our voltage source. And RR here, which has a zigzag line, is our resistance, or what sometimes we call it a load. So the black line connecting the voltage source and the resistance load is what we call our pathway, or our electrical pathway. And the current is flowing through that pathway. So we term it as I. So series circuit. So series circuit is having the same concept of simple circuit but with additional resistor. So we have now R1 and R sub 2. So R1 and R2 are connected. So one terminal of R1 and the one terminal of R2 are connected together. And we would solve the series circuit to make it a simple circuit to have just a singular R, a single resistance in a circuit. So we would convert complicated circuits to a simple circuit, which we would call it as a total resistance. To further our understanding in series circuit, we would use a water analogy. So imagine a water is flowing to two sand filters, the sand filter 1 going to the sand filter 2. So as the water flow for the first sand filter, the pressure of the water would surely decrease. And as it passes through the second sand filter, the pressure will decrease more. So the pressure flowing here has a very low pressure. Compared to the pressure flowing here, the pressure flowing here has a higher pressure. Okay? But still, the water okay? So still, the water that is flowing through the sand filter, so the water that is here, so the water is still equal to the water here. So what actually happens? So both the sand filter would be added together. It's like they are just a one big sand filter. So it's equal to just a giant sand filter. So it's the water still flowing, and going back to the pump is still equal in amount, and the pressure is still equal. Okay? So formulas to a series circuit based also from our water analogy. So we have resistor R1 and R2. So the total resistance is equal to the R1 plus R of 2. And as you notice that the current flowing through R1 will still be the current flowing through R sub 2. So our total current of our circuit, it will be IT is equal to the current flowing through R1 is equal to the current flowing through R sub 2. And our voltage, the total voltage, would be equal to the voltage across R1 plus the voltage across R of 2. As you notice, if R1 has a higher value, it would have a higher voltage. And if R2 has a lower value, it would have a lower voltage. And remember that we would use the Ohm's triangle to solve series circuit. Okay. Solving series circuit. So what if we add a value of our voltage R1 and R2? So as for our total voltage, we would have 18 volts. That's our voltage source. R1 would be 3 ohms, R2 would be 6 ohms. So first things first is we would convert this series circuit into a simple circuit. How do we do that? So we get first the total resistance, which is equal to R1 plus R2. Our R1 is 3 ohms plus 6 ohms, we would have 9 ohms. And we would redraw a circuit. As for starter, it's better that we redraw the circuit in a sheet of paper. So we have a voltage source and our total resistance now, which is 9 ohms. So redrawing the circuit. Now we replace now the two resistor with a single resistor called R sub T. With the same voltage source, 18 volts, we have 9 ohms. And we will now solve for the current, the total current. By using again Ohm's law, we just cover the cover the I, and we get now the formula for the current, which is voltage over resistance. Replacing the value of Vt, we have 18 volts, and our RT, which is 19 volts. And our total current now, 18 divided by 9, is equal to 2 ampere. As we say that the current flowing through R1 and the current flowing to R2 is just equal to the total current. So we have IT is equal to I1 and I of 2. So I1 is 2 ampere and our I2 is 2 ampere. Now our total voltage now is equal to V1 plus V2. And yet we only have Vt as 18 volts and we do not know the value of V1 and we do not know the value of V2. So we will be using again our Ohm's law. We cover our voltage, so we get the formula I times R. So our V1 is equal to the current flowing through R1 times R1. Okay? Make sure that if your number or the sub number of our variable is 1, or we are getting the V1, our I1 should also be 1 and our R1 should also be 1. Take note. Okay? So V1 now is equal to 2 ampere times 3 ohms. Our V1 is equal to 6 volts. So to get V2, it's either we use this formula, VT is equal to V1 plus V2 because we have already two variables, the VT and the V1, or we're gonna use the Ohm's law. So either way, we would have the same answer that V2 is equal to 12 volts. And we will put our results into a tabular form. As you notice, 3 ohms has a lesser voltage and 6 ohms has a higher voltage compared to the 3 ohms. And take note that the voltage across the resistor R1 and the resistor R2 is lower than the total voltage. Okay? So the higher the resistance, the higher the voltage across. So if you notice that the smaller value of your resistor has a higher voltage compared to the higher value of a resistance, probably there is a mistake in the calculations. So you can try on your own. So we just replace the voltage source with 12 volts, R1 with 4 ohms, and R2 with 2 ohms. You can pause the video and continue playing after you have solved the series circuit. So our next circuit would be parallel circuit. So we draw again a circuit, but with a different layout. So as you notice that one terminal of R1 and one terminal of R2 and also one terminal of voltage source, or the positive side of voltage source, are connected together. And the other end of our R1, R2 in our voltage source, or the negative value of our voltage source, are connected together. Again, we're going to make the parallel circuit a simple circuit. Okay? With just a single voltage source and a single resistance, which is our total resistance. So to further understand our parallel circuit, we again will use a water analogy. So imagine a water flowing through a parallel sand filters. So we have two filters, okay, the left filter and the right filter. So as you notice, the pressure flowing to the two filters are equal pressure. So we have only one pressure flowing on both of the filters. But the amount of water flowing through the first filter and the amount of water flowing through the second filter would be different. Okay? So we do not know if the first filter can make water flow easily, or this second filter would cause the water to flow lesser. Okay? So we still add up both of the filters and making a very small sand filter. So if we add up both of the filters, it's like a small filter because it has a different flow, different pressure passing through both of the filters. So now, based on our water analogy, we would derive the formula for our parallel circuit. So we can always draw the circuit that we have voltage source, the R1 and the R2, which are our resistor. So the formula for the total resistance, which is 1 over RT, is equal to 1 over R1 plus 1 over R sub 2. Now the current flowing through resistor R1, resistor I1, is different from the current flowing through resistor R sub 2. As shown in our water analogy, that the amount of water flowing to the sand filter, the first sand filter, is different to the water, or the amount of water passing through the second sand filter. So the total current now would be equal to the current flowing to resistance R1 plus the current flowing to resistance R sub 2. As you notice, we have here the voltage now is interconnected to resistor R1 and interconnected to resistor R2. So if there is no resistor R1, if there's no resistor R1, so if there's no resistor R1, we have a simple circuit. So the voltage is flowing through R sub 2. And if we don't have resistor R2, we can say that the voltage now is just flowing through resistor R01. So based on that assumption, and based on our water analogy, and the experiment of the German physicist George Simon Ohm, we can say that total voltage is equal to the voltage across R1 and the voltage across R sub 2. And again, we would not forget the Ohm's triangle. Now let's try solving parallel circuit. So again, we will draw the circuit with a voltage source of 18 volts and 3 ohms for our R1, 6 ohms for our R2. We are going to use the formula 1 over RT, which is equal to 1 over R1 plus 1 over R sub 2. Replacing R1 in R2, we get 1/3 plus 1/6. So solving this kind of equation, it's just solving a basic fraction with different denominators. Mostly in our circuits, we will be only concerned with addition. Okay. So the first thing to do in solving a fraction with different denominator is we get either the LCD or the GCF. Okay, so we get the LCD of 3 and 6, which is I choose 6. So either way, you can use 6 or 3. So 6 divided by 3, we get 2. And 6 divided by 6, which is 1, times 1 is 1. Okay, so we get 3 over 6. Now, can we still simplify 3 over 6? Definitely yes, because 6 is divisible by 3. So we get 1 over RT, which is equal to 1/2. Okay, what we need now is RT not in a fraction form. So we get that by getting the reciprocal of R of t. So as we reciprocate the left side of the equation, we should also reciprocate the right side of equation. So the general rule, if we add something on the left side, we'd also add something on the right side. So our RT now is equal to 2 ohms. As you notice, our RT is smaller than R1 and smaller than R of 2 based on our water analogy. Again, we would redraw our circuit to a simple circuit, having a simple voltage and a single resistance R sub t. So redrawing our circuit with a single voltage, which is 18 volts, and our total resistance, which is now our 2 ohms. And the current flowing through, the total current flowing to the simple circuit is our current I of t. Okay, so the formula now from our Ohm's law is equal to Vt over Rt. We just substitute Vt with 18 volts and Rt of 2 ohms. Our total current now is equal to 9 ampere. Okay. So going back to our circuit so that we could get current flowing through R1 and the current flowing through R2, we'd again use the formula of the Ohm's law, which is equal to V1 over R1. Remember, if we're getting I1 or the current across resistor R1, we should also use the voltage across the resistor R1 and of course our resistor R sub 1, which is equal to 18 divided by 3. So our current flowing through R1 is 6 ampere. And the current flowing through R2 is equal to I2 is equal to V2 over R2, which is equal to 18 over 6, and I2 now is equal to 3 ampere. So IT, if we add I1 plus I2, it should be equal to 9 ampere. And based on our assumption, or based on the water analogy, Vt is equal to V1 is equal to V of 2 because they are all interconnected to the positive terminal and the negative terminal of our voltage source, which is equal to 18 volts. Vt is equal to 18 volts and V1 is equal to 18 volts and V2 is equal to 18 volts. So now it's your turn to solve a parallel circuit. So we have a voltage now of 12 volts, a resistor R1 of 4 ohms, and resistor R2 of 2 ohms. So you can pause the video and try solving on a separate sheet of paper. So what if there is more than 2 resistors? Then we just add the additional resistor. So for series resistance, we have now a 3 resistor, which is R1, R2, and R sub 3. So the formula now of RT is equal to R1 plus R2 plus R sub 3. The total current is still the same of having 2 resistance. All the current flowing to the circuit are all the same, which is now our formula is equal to IT equal to I1 equal to I2 equal to I sub 3. And our voltage is just adding all the voltage across individual resistor, which is equal to V1 plus V2 plus V sub 3. In our parallel circuit, so we just add another resistance parallel to R sub 2. So we just add another fraction of 1 over R sub 3. So our total resistance now is equal to 1 over RT equal to 1 over R1 plus 1 over R2 plus 1 over R sub 3. And the current flowing is equal to the sum of all current across flowing through the different resistor. So IT is equal to I1 plus I2 plus I of 3. And since they are all interconnected, the positive terminal of our voltage source to the individual terminal of our resistor and also our negative terminal of our voltage source is interconnected to the other terminal of our resistance, we have equal voltage. So our Vt is equal to V1 is equal to V2, which is also equal to V sub 3. So now, what do you think is the purpose of series and a parallel resistor in a circuit?